This week, we're going to be talking about transformations of functions, which is taking a function and moving it somehow, shifting it left, shifting it right, up, down, maybe reflecting it across the X or Y axis, or making the function's graph skinnier or wider. Either way, we're taking functions and we are manipulating them and moving them around in some way. Now, in order for us to have the conversation about transformations, we need to talk about the basic functions. We need to go through some basic functions and some special points. In general, when we are transforming functions, we're going to have some function, and the points on that original function are going to move as we transform the function. And we want some special points for each function that we can go to when we're talking about transforming it. So we'll start with a real nice, easy one. Y equals x. We want to definitely choose the x value 0. -1 and 1 are great as well. And, we could choose different values, but I'm going to choose -5 and 5. The y value here is the same as the x value. So we have those. So we'll have the point -5, -5. The point -1, -1, 0, 0, 1, 1, and 5, 5. And that's what y equals x looks like. This isn't a really exciting one. We've done lines before. That's not super exciting. But it is important to keep these key points in mind, especially these guys in here. Right, those are the key ones. For x squared, we definitely want to use 0. We'll do -1 and 1, -2 and 2. These are just basic points on the graph of x squared that we can look at when we go to transform the function. These are good baseline points. For each of these, we are squaring them. So -2 squared is 4. This is the point -2, 4. -1 squared is 1. So we have -1, 1. 0 squared is 0. That's the point 0, 0. 1 squared is 1. That's the point 1, 1. 2 squared is 4. This is the point 2, 4. Now, I also know that -3, 9 and 3, 9 should be on the graph. I'm just going to go ahead and plot those so that I can make my parabola as nice as possible. All right. That is the graph of x squared. Really important to note that 0, 0 is the vertex of this parabola. We'll be talking more about quadratics in a tiny bit, but for the base quadratic, this is a quadratic function, and the shape is a parabola. Just because I'm saying those words out loud, might as well write them down. Quadratic is because the degree is 2. Parabola is just this shape right here. Anyway, this guy right here, this is the vertex of the parabola. That's just the lowest point here. That's where it changes direction. All right. X cubed. We're going to use the points -2, -1, 1, and 2. If we cube -2, we get -8. So this is the point -2, -8. If we cube -1, we get -1. So the point -1, -1. 0 cubed is 0. 1 cubed is 1. 2 cubed is 8. I wonder if, no. Notability is wonderful, but not that wonderful. All right, so this is a cubic function. And you know what? Like we have a name for this guy. This is a parabola, but I don't know if there's a name for this shape here besides it's a cubic. I'll look that up later. Unimportant right now. Important thing to note about this cubic, the base cubic function, raised to the third degree is what makes it a cubic, is that it flattens out here, not completely, but it starts to flatten out right here around 0. It's not a vertex, but it is an interesting point because that's where it starts to flatten out and changes from what we call concave down to concave up. So concave up is this shape, concave down is this shape. So this part right here is concave down, this is concave up, so it changes concavity there. That's something you're going to talk about a lot more in calculus. Absolute value of x, I'm going to use the same points that I used for my y equals x function because they are similar. The absolute value of -5 is +5. Absolute value simply is just making the number positive. So we have the point -5, 5. Absolute value of -1 is 1. Absolute value of 0 is 0. Absolute value of a positive number is just the number itself. So we have the point 1, 1. And we have the point 5, 5. Keeping in mind, this guy right here is the vertex of this absolute value function. Not that you know that, I haven't drawn it yet. I just got ahead of myself is all. All right. I am plotting all of these points. It doesn't want to play. Please. There we go. Close enough. This is the shape of the absolute value of x. For the square root function, we cannot choose any negative values. Negative values are not in the domain of this function. This is the first function that we've looked at so far in this base function list that has a restricted domain. The domain of a square root function is going to go in interval notation from 0 to infinity. So we cannot choose any x values that are less than 0. I'm going to choose 0. And I know that I have to plug these x values into square roots. So I want to choose square numbers for x, because if I choose a square number for x, when I take its square root, it'll be a nice value. So 1 is a square number, 4 is a square number, and 9 is a square number. The square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. This is the point 0, 0, 1, 1, 4, 2, 9, 3. And that is what the square root function looks like. So this 0, 0 point is important here because that's where the graph starts. Finally, we have the cubic function, not the cubic, the cubed root function. Did I do that in blue? I did. Let me maintain that consistency. Cubic root, it is a cubic root because it is the third root. We want to choose x values here that we can take an easy cubed root of. Nice property of cubic roots is they don't have a restricted domain like a square root. If you take the cubic root of a negative number, it will just be a negative. So the values we want to choose for x are going to be values that give us a nice cube root. So we want cubed values of x. We can use negative numbers. So if we look at what we want our y values to be, it can be a tiny bit easier. Well, maybe not. Changing my mind here. Here are the values we're going to use. I'll just tell you. These are the values we're choosing. You may ask, why would I choose these values? I'm just counting up the cubes. So 0 cubed is 0, so I know we should choose 0 as a value, which is right there. 1 cubed is 1, which is why I chose -1 and 1. And then 2 cubed is 8, which is why I chose -8 and +8. The cubed root of -8 is -2. So this is the point -8, -2. The cubed root of -1 is -1. The cubed root of 0 is 0. The cubed root of 1 is 1. And the cubed root of 8 is +2. Okay, that graph got a little weird there, but that's fine. So it looks a little bit like this. It actually looks an awful lot like the cubed function, but on its side. Interesting. All right, so these are our base function. These are our library of base functions. We're going to be doing transformations on them. So you want to know them. You want to know what they look like. You want to know these special points. All right, so in our next video, we'll start talking about transformations. I'll see you then. Bye.